You're watching the latest edition of Astraveo's Coast to Coast podcast of science, astronomy, and the world around us. My name is Joseph. He's David. And we're just two friends who happen to be professional astronomers with a deep love of telescopes, astrophysics, and all things science. So we've got a great show for you today. Astraveo's Astro Forecast for 2026. And we're going to give you the rundown on all the most exciting events, what to expect, and when. We do this for ourselves anyway because we like to stay on top of this stuff and try to get images or see what's going on. So we thought it'd be cool to share with our audience this year, and that way everyone who's listening can keep an eye out for this stuff as well. What do you think, David? Want to get started?
Yes, yes, I do. I know our audience are now used to me laughing at the start of this. You're finding more and more ridiculous images to send, so I start laughing at the start.
Yes. We've sold out. We're no longer organic laughter. It is now manufactured.
Still fairly organic. Well, I'm not going to share the image you sent as it was completely ridiculous. But oh my, that was pretty funny. Holy cow! Oh, jeez, Gina. Oh dear, dear. So okay, well, welcome to this brand new Astraveo on the start of 2026. Super exciting for Joseph and I, as he said. One thing I noticed yesterday, and this is the 4th of January here in the United States. Currently, there was a really what a so-called super full moon, a supermoon, yesterday. Is that of particular interest? What do we mean by that?
Yeah, so supermoon is when the moon appears a bit larger and brighter in the sky due to its proximity to Earth. It's the moon's orbit is not perfectly circular; it's an ellipse, so sometimes it's closer or farther away from the Earth, depending on if it's on the semi-major or semi-minor axis of its orbit. And when it's closest to the Earth, is called its perihelion, and it can appear a little bit brighter. There's a very funny XKCD about supermoons, where if we called Superman like supermoon, he would be something like 7% larger and 8% stronger than the average man. So if we do call it a super, it does look a little bit larger, and if you can view it low on the horizon, I think the effect will be pronounced. But it's not going to be like double the size. But supermoons are very cool, very beautiful. Yeah.
So you did mention an interesting thing about when you see it low on the horizon. The moon always seems to be much bigger on the horizon than in the middle of the sky. Does it
Yeah.
change size?
No, not to my knowledge. It does change size throughout the year, as I mentioned, due to just the slight changes in distance, but these are order 10% effects and no larger. But it does appear to change size throughout the night because our brains do better estimates of size when there's other things nearby. So it'll look very large in the horizon because there's other things whose scale we're familiar with, like buildings and trees. And so it's like, wow, it looks so big. But then it goes up in the sky and we can't compare it to anything else. And so it looks smaller by comparison.
Yeah, so it's a complete optical illusion, in fact.
Yeah.
Yeah. Okay.
Throughout a single night. Yeah.
Yeah, yeah, absolutely. Well, that's a great explanation of yesterday. Was perihelion. The Earth was closest to the Sun in its orbit, as it is. The orbit is elliptical or egg-shaped, as you
You
mentioned.
mean the moon is closest to the Earth, sir? Right, presumably.
Oh yeah, sorry. Yeah, sorry. No, you're 100% right. Actually, funny enough, the Earth was closest to the Sun yesterday as well. But yes, you're 100%
Just by
right.
sheer coincidence,
Yeah,
not a cosmic conspiracy.
no, that's right. No, absolutely. We could talk about this briefly, maybe. And I had this discussion with Benjamin, my 17-year-old, yesterday. Is if it actually Amber Morris the day before, my 10-year-old. If the Given that the Earth is closest to the Sun yesterday, why is it really cold here in Massachusetts in January? Shouldn't it be
Uh,
warm?
so this is primarily due to the weather machines created by the lizard people. Um, sorry.
Oh
uh,
God.
so even though we've been talking about how orbits are elliptical and there's a small difference between the semi-major and semi-minor axes of this orbit of the ellipse, the Earth's orbit around the sun is also elliptical, but it's a much smaller effect than the moon's elliptical orbit around the Earth. So the proximity of the Earth to the sun doesn't change that much throughout the year because it's so almost circular, and it even though it does change a little bit, it's not enough to cause any effect at all, basically on weather. The weather effect is entirely determined by the Earth's tilt, and so it's the Earth's tilt on its axis
Yeah.
that sets the seasons. Yeah,
Yeah. Can you remember the degree of the tilt from the perpendicular?
wrap. It's 27 degrees.
Oh, gee.
That's too large. No, I'm thinking of I'm thinking, wait. The Earth's tilt.
I'm gonna contact your PhD committee.
Yes, yeah. My PhD is gonna get revoked. I'm not a planetary scientist. Oh my god, what is it? I feel like there's a 7. What is it?
What are the latitudes of the Tropic of Cancer and Tropic of Capricorn?
What is it? Plus or minus 13 or something? I don't.
Definitely right into your PhD
Yeah,
committee.
I don't. Why would my PhD supervisor care if I know where the Tropic of
Don't do
Cancer
this.
is?
Rack
Can
your
you?
brain.
I actually don't know off the top of my head. What is it? Is it?
It's 23.5 degrees.
Oh, I was close with 27.
Yes, you were close, but in astronomy, details matter.
Oh my god, you made me think I was like tens of degrees off. I was 4. David, oh my god.
We're tens of 0.1 degrees off.
Yeah, exactly. We were billions of nanodegrees off. uh, oh my goodness.
Yeah, you're entirely right. It's the tilt of the Earth. It's not the fact that we're a tiny bit closer to the sun in January. 100% right.
So did you just say in astronomy precision matters? Have you familiar with the factor of 2, David?
Well, true. I actually said details.
Details, yeah. Good get.
I have to say I've stolen that line. There's a TV show at the moment called Reacher, and it's this ex military special investigation person, and he's really good at understanding the details of a case. And if somebody says something like that, with oh, it's a couple of degrees off, he says in an investigation, details matter.
I think that's why they did the casting choice they did for Reacher, right? Because of his attention to detail.
Well, that and he's about 6'5" and like ginormous. He's got these super muscles. Yeah, but that too. Yeah.
Okay, yeah. So we've learned that 4 degrees is important.
What?
Uh,
Yes. Well,
I feel way better about a 4 degree difference.
yeah, 4 degrees is pretty good. It's pretty good. Well, look, we're going to put the details of the calendar. I will actually give you an astronomical calendar in the details of the video, but with all the dates. But one date that's sort of jumping out at me on the screen right now is the 10th of January in about a week's time. It's my mother's birthday. Happy birthday, mother!
Good birthday.
Sure, appreciate that. Thank you. Is Jupiter at opposition? Now, why does that matter, and what does opposition mean?
Okay, so so for opposition, this is referring to the location of a planet in its orbit around the sun relative to Earth. So if this is I mean, I know I have the sun on the screen right here, but if this is the sun and then this is the orbit of the Earth, so here's the Earth. When a planet, if there's a planet outside of the orbit of the Earth, so for example, Jupiter's sitting out here, it can have any position in its orbit like this. And when it's on this side of the sun, versus when it's on this side, it's a lot closer to us. Also, because it is being sort of illuminated by the sun in the front, it's a lot brighter. So opposition is this point where the planet is closest to Earth and so it appears largest and brightest due to its orientation. This is like the best time for imaging.
Yeah, absolutely. So that's a great way of putting it. In fact, so Jupiter on that date is going to be the brightest it will be all year, assuming it's not cloudy, and it'll be visible pretty much all night long. And it's great right now in the northern hemisphere. I can see it from the deck outside my house here. I see it basically as once the sun sets, and it's there when the sun rises in the morning. And it is super bright. It's in Gemini right now. It's right near Castor and Pollux, the two brightest stars of the constellation Gemini. So it's very easy to find. Looks a bit like an isosceles triangle at the moment. Yeah, I believe you have an image of Jupiter that you yourself took from your decking out there in California.
Yes, I gave Jupiter a proper decking and took this picture at last opposition. So it's thank you. So Jupiter being at opposition, in addition to being very bright, which is good for imaging, it has its largest angular size on the sky, which means your telescope resolution goes farther. And so, at last opposition, we were able to capture all these details on the planet's surface and its moons, including the solar eclipse. And in this case, in this image here, we have sort of all 4 of the Galilean moons, Io, Ganymede, Callisto, and Io. And one of the cool things that just being at opposition enables, you can technically do it year round, but you get the best quality is you can do hyperlapses of the planets. This is one that I made sort of at a similar time. And this is in particular a hyperlapse of a solar eclipse on Jupiter. So you can see the moon there. I think that's Ganymede, and it's casting a shadow on Jupiter as the planet rotates and the moon orbits around it. And these are the kind of images you can expect people are going to be making around opposition because the quality of the images, you do shorter exposures, time lapses become more feasible, all sorts of fun stuff.
Yeah. Just out of interest, what's all that banded structure? Why is there so much banding? Why isn't it just cloudy?
So Jupiter is Jupiter is a gas giant, and the different colored bands correspond to different chemical compositions and interactions. In particular, that's what gives it different colors. But the reason it bands so heavily is because Jupiter rotates very quickly around its axis. It has a 10-hour orbit revolution period, a rotation period, and this causes the atmosphere to be incredibly turbulent. And we actually did a sort of deep dive into Jupiter and we did a deep dive into Jupiter and, Pickles, Pickles, buddy, it's okay, buddy. Sorry. My dog is going crazy. He's very excited. Yeah, he's very excited about Jupiter. "Come here, buddy. Say hi." "Grr." You know the rules, Pickles. You squeal on camera, you gotta say hello. Mwah. So, yeah, so, we did a documentary about this in our video, What Galileo Saw, which we'll link up to in the corner. You can go watch and, see how we make these images and how we, and learn a little bit about Jupiter and its moons.
Yeah, fabulous image there, Joseph. I really like that one.
Thanks, dude.
Yeah, nice job. And and I can see this, but our listening audience of the three members that regularly tune in cannot see it. Is there is I see a radiant map for the Quadrantids meteor shower actually to the tonight and basically yesterday or last night and tonight. If it is
Yes.
where you are.
This is happening right now.
So that is really exciting. Okay, it says 3 a.m. So holy cow, that's really late. Um, this is clearly in the northern hemisphere because I see the Big Dipper and Little Dipper. That's Ursa Major and Ursa Minor in constellation speak. What are we looking at? What does this radiant point mean?
So the Pickles, it's okay, buddy. The radiant point is referring to the spot on the sky that the meteors appear to come from. It's a common misconception that a meteor shower is something that happens to the Earth, but it's more like the meteors are sitting in space and then the Earth passes through them on its orbit. And so they'll come from one direction, which is the direction of the Earth's orbit or the direction of Earth's velocity around the sun. And that'll have a particular location on the sky depending on the time of year and the orientation of the Earth on its axis. And so this is showing where you can look in the sky, and all the meteors will appear to come from that direction, shooting across the sky instead of from like an alternative direction.
Yeah, no, nice. So why typically do they come from one given direction? I mean, you are right. The Earth sort of intersects that dust cloud or dust stream. Where those dust streams typically come from?
Usually, it can be a variety of sources, but I think the most cited one is like comet trails or
Yeah,
yeah.
that's exactly it. They're comet trails. I cannot remember the name of the comet that likely caused this meteor shower, but
Yeah, but we can
yeah.
usually trace it back because they sit in the orbit and don't move too far from it.
Yeah, no, yeah, we could do the orbital mechanics and figure it out. So that was January, pretty exciting. 18th of January, by the way, new moon. You typically get a new moon 2 weeks after a full moon, so that makes sense. Again, new moon you essentially cannot see unless there's an eclipse, right? Because it's blocking the sun. But yeah, so new moon is sort of relatively uneventful, except that the night sky is very, very dark, unless you live, near a city or a big town, because of course the moon is not polluting the sky with all its beautiful light. What's going on in February? Anything interesting we should care about?
Let's see. We've got the corresponding full moon, 2 weeks after the new moon, as
Let's
always.
see, early
Uh,
February, full moon. Yep.
And then we have a really nice annular solar eclipse. So, yep, those are always fun. So the solar eclipse in February, we have this map. Unfortunately, I think it will not be seen. But David, can you tell us about the difference between an annular solar eclipse and a total solar eclipse?
Yes, an annular eclipse occurs every year.
Oh my god, I was like, "Uh-huh, yep, right."
You were nodding for a minute
I
there.
know. I was like, "What the"
So no, an annular eclipse does not mean it happens annually. So it's just a misnomer. So an annular eclipse is when the orbital mechanics of the Earth Moon system is such that the Moon doesn't quite block out the Sun completely, and so in fact it appears to be slightly smaller. Yes, there's a wonderful picture, beautiful. So what you're looking at here is a real image of the sun is clearly in the background, and the moon has passed in front of it as in its orbit. And as I said, this is actually technically a new moon. And so what you're seeing is because again the relative distances between the Earth moon and the moon Earth moon sun are such that it doesn't quite cover the sun's disk like a total solar eclipse would. And we have a very nice Astraveo video that we did of that a few years ago when we had a beautiful total eclipse up there in northern Maine. And so really what you're seeing is almost like a sort of what you could class as like a ring of fire, and I don't mean the string of volcanoes around the Earth. You're essentially seeing this beautiful illuminated ring of the very outside of the disk of the sun. And you will see that in 17, on the 17th of February. And if you could jump back to the visibility map for me, please. Yeah, so this is a very beautiful event, but unfortunately, the vast majority of humanity will not see it because, as you can tell by this color-coded map, where the sort of light greens into orange into red, which you'll obviously the red track there that looks like almost like a C on its side having a nap. That's where the greatest visibility path is. The vast majority of the yes, right there, thank you. The vast majority of this event is going to take place over Antarctica, which is the great big land and ice mass there at the bottom of that image. The very bottom of South America, so Patagonia essentially for Chile and Argentina, right there, thank you, with what looks like the Falkland Islands. They will get some visibility. It looks like Madagascar, South Africa, and maybe Namibia, not Namibia. Is it Mozambique that's up there on that side? The very eastern South Africa will also get some visibility, but essentially the vast majority of us most of the land masses and the continents of the Earth will not be able to see this. So it's a bit of a shame.
Thanks, David. But stay tuned because there is another solar eclipse happening later in the year that more of our audience may be able to see. But besides that, in February, we also have a very interesting and a little bit rarer of an event. Mercury will be at its greatest eastern elongation, which I think is really cool. So, David, Mercury is one of your favorite objects. So, can you walk us through what this is and why it doesn't happen? Why it's so hard to see Mercury
Yeah,
properly?
that's a really nice one. You're 100% right. Mercury is obviously the innermost planet. It's the number one planet in the solar system, as in the first out from
Number one by some metrics.
by some metrics, by how far it is from the sun.
Exactly.
Very beautiful object. I really like Mercury, but because it's so close to the sun, because from here this image is perfect actually. As you're looking in toward the inner solar system, Mercury appears to be always very close to the sun because we're of course looking in. GDP. Oh my gosh, that's quite. And so what essentially that means is you never ever see Mercury far from the sun. So for instance, you generally don't see Mercury, say, in the middle of the night because the sun will have set 6 hours ago. And so what we mean by greatest elongation is in its orbit and the relative orbit of the of Mercury Earth relative to the sun is you see it as far as it can be at that particular time away from the sun. Now, on the 19th of February, it happens to be about 18 degrees, about 18.1 degrees. And because it's eastern elongation, it's east of the sun, which means if the sun sets in the west, the Mercury is just slightly east of it, which means you'll be able to see Mercury for about an hour after sunset. Of course, very low down on the horizon, so you'll obviously have to have a clear horizon or be on the west coast of America, for instance, to be able to see it well. And so I love it. Mercury is a beautiful object. Very, very. It's quite faint. It's not quite as bright as Venus, although not much else is. But it does look distinct. And so it's a very beautiful object. And there are actually several great elongations of Mercury this year. So Mercury is quite visible for Earthbound astronomers this year.
And I'm sure a lot of people are going to be busting out their scopes to try to get it because it's usually pretty hard to catch it. So you want to take advantage of any elongation, any elongation you can. Um, okay, so there's also it looks like a planetary parade with no Mars. I think this is our only planetary parade of the year. Yeah, you want to walk us through that as well?
Yeah, absolutely. Yeah. So the end of February, 28th of February, just after my sister's birthday, funny enough, there is this so-called planetary parade. Now, as we have done on a previous video here in Astraveo, all the planets in the solar system very closely line up along what we call the ecliptic plane. That's basically the plane of the solar system. And so, yeah, something like that, exactly right. So in this image, you see that most of the planets line up. Now, there is a little bit of, they can be slightly above, slightly below the plane, depending on the orbital mechanics, but essentially they appear to line up in the sky. And you actually get these lineups, these parades all the time. It's just that sometimes some planets are east of the sun, sometimes they're west of the sun, but so it's somewhat rare to see them on the same side of the sun in a line. It happens, maybe every couple of years ish. But, with the exception of Mars, all the major planets that are visible or easily visible, do line up. Now, don't forget, for Uranus and Neptune, you will need a pair of binoculars or a small telescope. But, Mercury, Venus, Saturn, and Jupiter are, of course, visible to the naked eye. It won't be great on this particular date, although it might be pretty because you'll have a fairly full moon. When is I'm just looking at the date, a new moon. Yeah, it's a fairly full moon, um, on the 28th of February, so it's probably gonna be something like 85, 86% illuminated. So while Jupiter and Venus will be easily visible, uh, Saturn and Mercury will be difficult to see. But these so-called parades are quite pretty, and you can get some nice photos if you're in the right place.
Thanks, David. Yeah, and I want to bring up as well that so Astraveo has our own sort of suite of planetary parade images. So this is the one we took during the planetary parade about a year and a half ago. And so you can go out and you can, because all the planets are up, you can go and make all as an image of all of them if you can. We want to also debunk some of the stuff that was floating around during the last planetary alignment, especially this idea that these planetary alignments are particularly rare and that they only happen once in a billion years. This was floating around a lot, like this article, which we have decided out of grace to not cite a source for because we're going to clown on it a little bit. But one of the big pieces of misinformation that was floating around was that this is such a rare alignment because it involves all eight planets, and that happens only once every 396 billion years. As a reminder, our whole solar system is only around 5 billion years old. The whole universe is only around 14 billion years old. So this is a patently ridiculous thing to say. Also, you can calculate how frequently this should happen. If any given planet has like a 50% chance of being on one side of the sky, the probability that all eight of them will be is just zero point 0.5 to the 8, which is about 0.3%. So around once every 300 to 600 days, you might expect an alignment like this, which is exactly what we see happen once every couple years. This happens. And this article that says only happens once every 396 billion years seemingly does not see the conflict with this because it then states that the last time it happened was December 22, decidedly less than 396 billion years ago. So we just wanted to lay that misinformation to bed and debunk that once and for all.
That's really good. I mean, planetary alignments occur all the time, of course.
Yeah.
And by the way, these are beautiful astronomical events to take pictures, and you can get a real sense of the sort of the line, the orbital plane of the solar system. But there's nothing particularly special. That there's no going to be calamities and tidal waves and volcanoes, and it's just a beautiful celestial event.
It's a fabulous time for Star Tours because you can see everything in one night.
Yeah, that's right. People at
Like,
star parties love it. Yeah.
yeah.
Um,
Okay, David, oh, sorry.
no, no, after you.
I was gonna say you want to take us through March and April, or
Yeah, so
yeah,
but well, March is fun because, of course, if we have a total or near total, that's not true, an annular solar eclipse on the 17th of February, whenever you have a solar eclipse, you must have a lunar eclipse about 2 weeks or after or 2 weeks before. Now, in this particular case, the lunar eclipse is about 2 weeks after, and so on the 3rd of March, we will have a total lunar eclipse. And so here is looks like the visibility map that Joseph has brought up. And as you can see from the shading, Europe essentially and all of Africa will not see it at all. The western side of South America and most of the west of the US will see it. And then for Russia and Southeast Asia, they will also see it. But really, where is it down there? New Zealand get to see it really nicely. So the total lunar eclipse, sorry, on the 3rd of March will be quite beautiful if you're in any of those locations.
and we have Astraveo. Both David and I have imaged total lunar eclipses before, so this is David's image. David, do you want to tell us a little about the hardware for the image and the experience to capture?
Yeah, it was my DLSR, and I think it was it's a Canon. I can't remember the exact specifications now, but it's got something like a 4 centimeter aperture, and I can't remember the exposure times, but I think the exposure times were of the order of 4 or 5 seconds. Obviously, the larger exposure times as you go toward totality, which is the image in the middle, just because there's a lot less light coming off the moon, and the brown reddy color you're seeing is essentially scattered light coming through Earth's atmosphere and being refracted round to the sun, the moon. Sorry. So this is a mirror image, and in fact, you produced this. So there are only actually four distinct images. So you have the full moon, fully illuminated on the top left, top right, top left, no, top left, bottom right, and then a somewhat the beginning of the eclipse. It looks like it's sort of Pac-Man has bitten into about 20%, 30% of the moon on the second image there on the upper left and lower right. And then the third image, which looks like about halfway through the eclipse, you see this beautiful half-covered moon. And in fact, this disproves the flat Earth idea
Yep.
because, of course, the terminator, the line between dark and light, yep, is curved. So obviously that means the Earth is curved. And then the Earth, of course, is doing the obstructing in this case. And then you get the totality right in the middle, where, as I said, you get this beautiful red-brown color image as the sun's rays are passing through the Earth's atmosphere and being refracted onto the moon.
So in a sense, you're kind of the only light at that point that's touching the moon is light from the sunsets all around Earth because they're passing through the Earth's terminator.
Yeah, that's actually a really nice way of putting it. Yeah, I love that.
Yeah, and so did a similar image as well. I used a little bit different hardware. So I was using also a DSLR, my Canon EOS ST6 Rebel, but I connected it to my 6-inch Schmidt Cassegrain telescope. And so, whereas I think in David's image, like to give some context for this angular size there, I think in David's image, the moon was probably about this size for the full frame. For with when you hook it up to a telescope, my DSLR frame was about this size relative to the moon.
Yeah.
This actually required for each shot taking multiple images of the moon in different areas and stitching them back together. But this let me do some really fun stuff. Like, for example, I was able to take multiple exposures when the moon was starting to get really occluded and stitch them back together. And you see the red that's starting to creep in even during the before the moon has been sort of fully illuminated. Because I can take one side of the moon at a much higher exposure and higher ISO, and then the other side, balancing it. And of course, the money shot. Um, but lunar eclipses are very, very, very fun to make pictures of. And some people have spectacular like visualizations of the Earth's shadow. I know that's a thing people love to do. Is People will make these visualizations where you take the lunar eclipse and then arrange the moons in such a way that you can see the shadow of the Earth in total, and I just think that's the coolest thing
Oh,
ever.
it's so cool. Yeah.
It's so awesome.
It sort of
Uh,
reminds me a little bit of Archimedes' spiral, actually.
well, I think it's actually you have to arrange it in a particularly geometric way in order to make that happen. So I do think I think they're related,
yeah, very beautiful. That's
right?
a nice piece of art right there. What? I say it is. It's not. It's a piece of artwork.
Oh, art.
Yeah.
I thought you said something else.
No, no,
Uh,
it's a beautiful
it
piece of art.
is a very beautiful piece of art. Yeah, okay, so, that's our March 3rd total lunar eclipse. Definitely check it out if you're in one of the, regions of privilege.
Yeah,
Uh,
regions of privilege.
if you're Hawaii, you're up.
Yeah, I see Hawaii in the middle of the Pacific, and then New Zealand. They have absolutely phenomenal shows.
Hawaii gets all the fun.
Well, in general, it does. Yeah.
Okay, yeah, so that's our March lunar eclipse.
Well, yeah. Well, we also have something really nice occurring in March, and I always love this just because the visualization of it is on the 20th of March. About I'll do it here in the US. It's going to be about 9:45 in the morning. The sun is going to pass basically from the southern hemisphere toward the northern hemisphere. It's going to cross the celestial equator, so you'll get 12 hours of day and night across the Earth, and essentially we call that the vernal equinox. So it's the northern vernal equinox. And in the south, obviously, they call it the autumnal equinox because it's passing into autumn. But it's very beautiful. I always love that date actually, as the sun comes from the southern hemisphere to the northern hemisphere.
Yep. So mark your calendars. Make sure you feel the vibrations change as the sun moves. Okay, and I think we're going into April now. What do we got for us?
Yes, yeah, we're down into April. We have a full moon just after the beginning of April on the 2nd. Sometimes it's called the pink moon or the fish moon or even the sprouting grass moon for sort of obvious reasons. And then we have one of these lovely greatest elongations again.
Sorry. Whoa, whoa, whoa.
What?
How is fish moon obvious?
Well, it was so the fish moon was actually by the North American natives, the indigenous people from North America, because I think it's the type of fish, and I can't remember what it's called. I think it's the shad. They come inshore and typically up into estuaries to spawn, and so in early April. And so full moons near early April were known to be by the Native Americans, the indigenous people here, to be they were called fish moons.
Yeah, you and I are gonna have to talk about what constitutes obvious. Oh, and that.
I think the obvious was the sprouting grass. I think for
Oh,
that's the bit I meant by obvious.
gotcha. Oh, pickles. It's okay, buddy. It's okay. Okay, thanks, Dave.
Yeah, just as the grass started growing as the spring sets in the northern hemisphere.
Gotcha. Okay, yeah. So that's really exciting. That'll be beautiful. Take a picture.
Yeah, that will be that really. Yeah, that's absolutely lovely. And then, as I said, on the 3rd of April, we have Mercury at its greatest western elongation. And so what that means, just before or just after before sunrise, this time the Earth will, the Mercury will be rising just before the sunrise, and it's actually quite a big elongation. It's 27.8 degrees, which is about 1 hour 45 minutes before sunrise. Mercury will start to rise, so you should be able, especially if you're near the, let's say for instance, the east coast of the US, you should be able to see Mercury well above the horizon before the sun rises. So great opportunity for some nice photos there.
It'll be very pretty. I know we're gonna because I think that's gonna be it's gonna be even like a 30% longer or maybe 25% larger elongation than the February one. So I know
Yeah.
people are gonna be really excited about that.
Yeah, no, super, super nice. And then we have another meteor shower on the 22nd, 23rd, the Lyrids. The radiant point is in Lyra. Oh, yeah, there you go, got it. Lyra is Alpha Lyra. I think Alpha Lyrae, is Alpha Lyrae also called Vega, I believe?
Uh, I think so. Oh, I'll be honest. I don't. Yeah, I'm not sure. So I wanna. It's okay to say I don't know.
Yeah,
I can look it up for us though.
but I'm 94.7%.
It is Vega. Yeah.
It is Vega, yeah, I thought so. Yeah, so Vega is obviously a beautiful star. Is you see it a lot in pop culture, and for those interested, it's the sort of star, sort of the civilization that was contacting the Earth in the film Contact. A very bright star. It's one of the summer triangles, the brightest star in the summer triangle. Yeah, so the radiant point there, and again, I can't remember the name of the comet that caused this one, but yeah, a fairly nice little meteor shower there for April.
For astronomers too, Vega is the reference star. I think for the photometry. We use it to
It is. It's the
yeah
star. It's it was
for AB magnitudes, right?
it's very big magnitudes at 0.0 magnitudes exactly correct, and its nominal temperature is set at 10,000 degrees. And it also means that it's pure white, so its magnitude is 0 in all filters. So its B minus V is set to be 0.0, which is spectral type A0, a dwarf A0.
I love that you know all that stuff off the offhand. It's amazing to me.
Well, a bit geekism, and probably should have been out playing as a kid or something.
Geekism sounds like discriminating against geeks.
We're geeks. We're off the screw. We are geeks. We're part of that.
No, I know, but geekism sounds like you're geekist.
No, go. Sorry, geek and pro. Geek and pro.
Yeah.
Definitely gonna.
I subscribe to Geek is Geek. Yeah. Anyway. Okay. So is that for all for April? And then
That's the majority of April. So do you want to take it into May?
sure. So for May, we have the another full moon. This one's the flower or corn planting moon, also from Native American sky tracking. And then we also have the Eta Equinox meteor shower. Did we add a map for that? I don't think we did,
No,
but
I don't think so.
we'll probably have a video closer than talking about it because that's pretty far into the year. And then, of course, I think we have our first blue moon of the year. So, blue moon is, of course, when the moon goes.
Does it turn blue?
It is. This is at the time when the U.S. government dumps a bunch of antifreeze onto the moon to keep it and turn to the rich shade of blue. No, so a blue moon doesn't have anything to do with its color. A blue moon is blue because it has a if you have a full moon that's twice in 1 month. So the lunar cycle is 28 days. So every now and then you get one full moon on the first, second, or third, and a second full moon of the last couple days. And so we call it a blue moon for reasons. And do you know why it's called a blue moon in terms of like why it's blue?
No idea.
Not try. But
I may pick you up on something. The moon orbit around the moon's orbit around the Earth, the sidereal month, is actually 27.3 days. It's not 28.
uh well played. Well played, sir.
It's
You
also,
just
by the
you
way,
just wait until you say the year is 365 days. I'm gonna get you with that
yeah,
sidereal
yeah,
stuff.
there's
Point two five, exactly.
Actually, this is a really nice little tie-in, and it's sort of old English basically. But the word for month comes from a mooth. It's essentially when you have. It's basically full moon to full moon, and so that's where the English word month comes from. It's one mooth.
That's extremely cool. I think I vaguely heard something like that, but I didn't. Yeah, that's really cool. Oh, is that why we call it day? Because like all the days end in day, and so we just call that a day.
I guess so. I suppose.
Yeah, it must be right.
Oh yeah, I don't know. It's a very good
uh,
question.
no,
But yeah,
it's not.
to summarize that, a blue moon is the second full moon in a calendar month.
Yeah, and but it won't look. It's not like it'll look anything special, but it's just cool to
Yeah, yeah, 100% right. So.
Okay, would you like to take us into June?
Oh, you want me to do June? Okay then.
Yes.
June, there's a couple of interesting things. The new moon on the 15th, which sort of makes sense given that the full the blue moon, the full moon was at the end of May. Mercury has another greatest elongation, this time in the east. So you'll be able to see it in the west just after sunset. So for you, Joseph, who lives on the west coast, you'll see Mercury if it's clear about an hour after sunset. It'll still be visible, and it's a 24.5 degree elongation this time. So in fact, as the sun sets, the Mercury will be a full 24 degrees away from the horizon. So as it's moving into twilight, you might be able to get some really nice photos of Mercury, and even maybe be able to see the phase if you're lucky, which is just
That'll be really cool. That's the goal.
very. Of course, if there's a new moon on the 15th of June, about 14 days later, roughly, 20 or half of 27.3, uh, you will see another full moon, and that's sometimes called the strawberry moon or the rose moon or the honey moon. Not as in a honeymoon, but the honey moon. And that's on the 29th of June. But that will, of course, straddle the summer solstice, the northern summer solstice, or the winter solstice if you're in the southern hemisphere. And that's essentially when the sun gets as far as it can, as far north in the sky as it can possibly be. So the sun's declination will be 23.5 degrees north, which means if you live anywhere at latitude 23.5 degrees north, at midday, the sun will be directly overhead. And that occurs on the 21st at it's about 3 o'clock in the morning if you're in New York City or on the East Coast.
Very exciting.
Yeah, I really like the solstices, I have to say.
Yeah.
Yeah, do you want to take us into July?
Yep. July we have another meteor shower. So the Delta Operids, which are their radiant will be in the constellation Aquarius. That'll be at the end of July, which will be accompanied by a full moon. So that's going to make it kind of difficult to see the meteors, probably. But if you look right after a moon set or before moonrise, depending on what time of day it is, you might have a chance to see some meteors.
Well, I'm really, 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 really 10 to the 4 glad you said that. Given that it's a full moon, you actually know when moonrise is.
Oh, right. Full moon. So moonrise will be at exactly sunset. Right. Yeah, yeah. Sorry. Yeah, yeah. So sorry, sucks to suck, I guess. No meteors.
Yeah, the meteor showers are very, very different to see with a full moon. Yeah.
Right. And then there's accompanying new moon mid-July as well. So maybe you can catch because the meteor showers are not on a specific day; they kind of occur within a whole week. So you might be able to see something
Yeah.
within the week before.
Yeah, and if you're really lucky on the 30th, of course, the slightly gibbous moon, the waning gibbous, will actually rise an hour later on the 30th. You might still be able to catch some of those delta aquarids on the just before the moon comes up on the 30th.
Yeah. And you want to take us through August, David?
Yeah, August is exciting. It's actually a nice busy month. Specifically because let's do the sort of biggie is let's do the simple one first. Mercury's got a really nice elongation, 19.5 degrees in the east before sunrise. So you'll see a western elongation there. But we have a total solar eclipse on the 12th. So this is really pretty. This is similar to the one that Astraveo described again a couple of years ago now, back in I think it was April 2020.
23. Yeah.
23, yep. I was up in northern Maine, took all those nice pictures. Now, this one is a little bit funky, though, because if you're on the east coast of Greenland or the west coast of Iceland, and then in northern Portugal and Spain, you'll get a really great view of totality. Unfortunately, again, most of the Earth's humanity will not be able to see it easily.
No, but Spain is significantly more accessible than McMurdo Station. So, I mean, you're seeing, you're seeing, like, trips to Barcelona and stuff skyrocketing, people planning this. There's gonna be a lot of people in Iceland and, yeah.
Yeah, I've actually, funny enough, I thought about going to Iceland. It's going to be super expensive though, but it might be worth just sort of flying there and then maybe not even getting a hotel, just staying up for a couple of days and
The problem is that you're not gonna get the total eclipse, right? Because
it's
totality is off the coast.
well, I think you will, but it's for a very, very short time. I think there's a peninsula up in northwest Iceland.
Oh, I see it.
Yeah, right up in the corner. But I
Yeah.
think totality is of the order of like 30 seconds. Where I can't remember the exact totality of this one. I think it's several minutes, but of course, the longest it can be is about 6, 7 minutes. I can't remember the exact number.
It's, 7 minutes, yeah, based
It's
on
7
my head.
minutes, yeah, so 7.5, yeah. But this northwest peninsula of Iceland, I think, is only going to get it for a really short time. So financially, it's a big expense to go there to see 20 seconds of a total eclipse. I mean, exciting.
Yeah.
And of course, there's just not much sort of social and civilization infrastructure there in eastern Greenland, so that's going to be a very tough one to do as well.
Uh, but I mean, you could I'd pay to go to Iceland anytime, so
Yeah, I mean, I've been to Iceland. It's very beautiful. You see the volcano. I saw the volcano going off a few years ago, and then of course there's all the ice fields. Just stunning, stunning place. Just beautiful, beautiful culture, and people are so friendly as well.
Yep.
Very interesting culture. Of course, if we have essentially a new moon on the 12th for the solar eclipse, that must mean we have a full moon about 2 weeks later. So on the 28th of August, we'll have a partial lunar eclipse. So this one is still exciting, like a typical lunar eclipse. However, this time it won't go into full lunar eclipse, so you won't get that reddy brown image that we discussed earlier. Still very pretty, of course, but just be aware that even though the solar eclipse is total, the lunar eclipse is not. And then something exciting, I know that you like, because you're a great astrophotographer. It's on the 15th of August, so the Ides of August, you get to see Venus at its greatest elongation. It is the eastern elongation. So 45 degrees, it is about 45.9, so 46 degrees. Just after sunset, you will be able to see Venus toward the setting sun. And so Venus will be very, very bright. The greatest elongation is often coupled with high phase and being very bright, of course. Well, actually, greatest elongation, the phase must be a half.
Yes, I think during the last, greatest elongation, I got this, picture of Venus and because it's a half phase.
It's a half
Yeah.
phase. There you
Yeah.
go. Okay, I was just thinking of the geometry in my head. It has to be a half phase, yeah, or
Venus is, like, the easiest target to spot too with your naked eye, and if you can get a telescope, it's so worth it because I don't know why, but seeing a planet with such an aggressive phase is, like, one of the most stunning things.
Oh, stunning. Well, of course, it's the third brightest object in the sky, so
Yeah.
sun and the moon is very easy to see, very beautiful. And so that's just one of my favorites. So yeah, 15th of August, you'll see Venus shining brightly in the west just after sunset. So beautiful. So you want to jump into September for us?
Yes. So September, the 11th of September, we'll have a new moon. Following up our following up the exactly almost a month after the new moon causing the total solar eclipse. And September, of course, we're gonna have the northern fall equinox, and the sun's gonna go back across the equator. So that'll be fun, and that'll occur at exactly it looks like 6 minutes UTC on September 23rd. And that'll coincide with a full moon. And right around then, also very exciting, Neptune will be at opposition. So Neptune comes into opposition once a year. Unlike the closer planets like Mercury, Venus, Mars, which their oppositions, or like Jupiter, for example, their oppositions are determined both by the Earth's orbit and their orbits. Uranus, Neptune, their oppositions are basically just determined on when the Earth crosses over to their side of the sun because they move so slowly relative to us.
Yeah.
And so this is Uranus at opposition. I thought I had
Yeah, that was
Neptune
yours
as
as
well.
well. I was just
Yeah.
gonna say.
Sorry. Well, here's Neptune here.
They're
They're
very
putting there.
similar because they're both fairly blue.
Yeah.
No, we've
And
discussed
yeah.
this. Sorry to interrupt. We've discussed this in another video. In fact, I think it was when we did the planetary alignment video. Why are Uranus and Neptune so blue to the naked eye or through a telescope?
Um, well, first, they're actually not. Neptune and Uranus are both kind of a like aquamarine color. And yeah.
Bluish then.
Oh, well, their the chemical composition of their surface is primarily do you remember what it is? But it's because of their chemical composition that they're very homogeneous. It's like methane,
Yes.
is it?
Yes, so it is. So might also catch you there. You said on their surface, they are gas
Oh yeah,
giants.
they're gas giants. But I mean,
They'll have a surface.
yeah,
But
yeah,
but at least the extensive cloud decks have got an awful lot of methane in them.
yeah.
And the methane molecule, it's CH4, one carbon, four hydrogens, is wonderful at absorbing red light. And that red light essentially makes it vibrate and rotate. So the so-called row vibrational modes. And so when you get the Roy G. Biv, the rainbow from the sun, methane molecules sort of absorb very, very well the red, the oranges, the yellows, and so you're left with the G bibs, the green and the blues. And so that's why those two particular planets look green, teal, turquoise, whatever you want to call it.
Something very interesting about Neptune is if for a long time people thought it was this color, and this was primarily because one of the Voyager spacecraft flew by and they oversaturated the image. And then very recently, an astronomer did a re-imaging of the data. Copy the image link here. They did a re-imaging of the data and found that what is going on? I'm trying to copy image link then paste. There we go. And found that while this is the sort of image that everyone's familiar with for Neptune, this is the actual color, and it's basically identical to Uranus because of their similar chemical compositions. I am guilty of this myself. I mean, I 100%. When I imaged Uranus and Neptune, I experimented with this, and they are almost identical in color. But if you turn up the saturation on Neptune, you do get it to look like this, and that's pretty much where the color, that fancy color, is coming from. But I've always thought this was interesting. That just for a long time, this was the picture and the zeitgeist of Neptune,
Yeah,
and
absolutely.
yeah,
Yeah, the sort of, as you say, the zeitgeist and popular culture is like, oh, it's deep blue. Like, yeah,
yeah. It's very nice that it's deep blue and rains diamonds, and it's like,
yeah, that's right. That definitely doesn't rain diamonds.
well, I think I did hear that was a story that was going around for a while. Was it Neptune or Uranus?
Yeah,
Uh,
absolutely. But yeah, definitely isn't.
yeah, yeah, yeah. So it was Neptune. It was Neptune. Yeah, there were a lot of articles that were very confidently kind of saying stuff like this, which is like, yeah, okay, yes, carbon can crystallize in the upper atmosphere, but it's not. People picture it like this, like it's raining
Yeah.
perfectly, polished diamonds. It's like not quite.
Yeah, no, we could do a video about that one day, sort of debunking the sort of the astro myths.
Oh, that's a great idea.
Yeah.
Comment below if you'd like to see that.
That's right. Absolutely.
Like and subscribe.
Yeah, that's right. Let's hit our subscribe button. I have to say that one of the things about YouTube that annoys me the most is like, don't forget to click that bell and do subscribe. It's like, I'm already watching the video. Of course, I like your content. Don't worry, I'm probably gonna subscribe. You don't have to tell me.
I'm actually the opposite. One of the things that annoys me the most is when the video starts, there's 5 seconds, and it's like, "Don't forget to like and subscribe," and it's like, "You haven't even shown me anything yet." 100% of my perception of your comment is you asking me to like and subscribe.
Well, the really funny part of this conversation is I think at the end of all our videos is if you say if you do like the video.
But we put it at the end after you had a chance to see if you like us or not. It's like anyway, sorry. Sorry, that was September.
All good. Why don't you do October for us?
Okay, so October, we've got Saturn at opposition. So that's gonna be really exciting. Saturn's gonna be big and bright, and Saturn is a beautiful target image. So these are two Astraveo images, not quite from Saturn's last opposition, which happens roughly once every, I think, 14 months or so. But these two images are cool. This image was taken with actually both images were taken with a 6-inch telescope. And in this one, you can see three of Saturn's moons, including Titan, which is the big boy. One of the cool things about Saturn is pointed out that David pointed out that if you look at the ecliptic, not all the planets sort of fall exactly on the line. Some of them are above, and then some of them are below. And that uh, I believe that this is what causes us to observe Saturn's rings tilt differently, right? If we're literally looking at the planet from a different angle in the ecliptic because of slight variations uh, I think that's the cause.
Yeah, I'm not thinking about that. If we're here,
Because so we see Saturn's rings as edge on when we are at the same degree of inclination in the ecliptic due to the orbits crossing.
I think that's right. Yeah,
Yeah.
the orbital planes cross because yeah. So here's the sun. Oh, wrong way around. Oops, do that. Here's the sun. There's us. And so with Saturn here, it's the Earth's orbital plane crossing with Saturn's orbital plane. Now I'm exaggerating; they're not really like that bad. But yeah, you're right. Sometimes Saturn is below the plane, and sometimes it's above, and it just depends on the orbital mechanics. But you're right; the ring orientation does change, and I can't remember the periodicity, but it's in the celestial mechanics, which are non-trivial.
Oh, I remember. So we see the rings. I believe it's on a 7-year time scale. That's like the periodicity of it, I think.
Oh, is it
Uh,
seven?
7, yeah. So I think so. And so these images were taken about a year apart, and what you can see is this is the earlier one, and we could see more of the rings. In fact, amazingly in this image, with just a 6-inch telescope, you can see Pickles is sitting directly on my arm. So as he's moving my mouse. So you can see the Cassini division, which is pretty incredible, I think. With just a 6-inch. Yeah, yeah, yeah. You can see it. I can try to zoom in on that. That's one of my favorite shots because you can see the Cassini division fairly clearly.
Oh, there
Okay.
it is. I see it.
There it is, yeah, and there is on the other side too. I just think that's so cool. But you can't see it in this image because the rings have now tilted and they're almost edge on. And so, about a couple months ago, the Saturn was completely edge on,
Yeah.
and so you couldn't see the rings at all. But now we're gonna start seeing it from below, so you're gonna see the bottom side of the rings, that'll get more and more until you see Saturn in all its glory when the rings are tilted at like a 30-degree inclination relative to us. That's like my favorite. I That is like my goal to image that when it's at full tilt.
Well,
But
you what you could do is if you take images regularly, and this year is a pretty
you
good
can make a time lapse.
take time lapse of the tilt of the rings changing.
That would be a 7-year project, though, is the thing.
Okay,
Yeah.
it's okay. Just like our PhDs, right? They take 5
That's
years.
true. That's true.
You know,
I think someone's done this. Saturn ring read. It's height. I'm sure. So I'm almost 100% sure someone has made an image of this. Yeah, like here we go. Here we go. This is a great one.
wow, look at
Yeah, so striking. Um, Here's another. I'll just open a couple of these real quick. Um, yeah, I mean,
oh
it's remarkable.
yeah.
This is where we're at now. Oh, 2025. Yeah, right there. So we're at this right now. And you can actually see this is when I took that first image in 2023, and this is the second one in 2024. And you can see the same tilt,
Yeah.
or the same
Well,
tilt
well,
level.
keep taking images because obviously you've already got 2 or 3 years history
Yeah, right.
in sequence.
We can keep going. I never got them edge on though. I should have.
Well, wow,
But this one's so amazing.
that's a great one.
It's Saturn's always like striking because of how 3D it looks because you have the rings.
Yeah, that's right. I also like the back. I like the eclipse of the rings round the back.
Yes, you can see this in my images as well, actually, which is crazy. So you can see it. You can see it right there.
Yeah, and you can see
Yeah,
the it itself
the
gets
shadow.
in its own shadow, yeah.
Yes, right here.
Amazing.
It's so cool. It's like the coolest thing to me. I don't know how well you can see it here. Yeah, you can't really. You can see the shadow a bit. I think you can see the shadow. But no. Oh, right there. Yeah, you can see the shadow on the rings.
Yeah,
Oh, it's sick.
that is so
Okay.
cool. Nice.
Yep. So, all right, and so that's for October. We got Saturn opposition, the Draconids meteor shower, which we'll talk about later in the year as well. But that's of course the radiant will be from the constellation Draco. That's the skinny guy from Slytherin, and we'll have a new moon around mid-month. Mercury will be at again its greatest eastern elongation. I don't know if you've noticed that I've been doing this, David, but
Just been
I'm,
yeah.
I've been flipping them.
Yeah. No, oh, yeah. No, I noticed
Mercury.
that. Yeah.
This is a high quality technological advances you get from Astraveo. To see what
We're
people.
normally pretty good at the images. This one, you just like, hey, let's do the calendar for 2026, and we'll just do a 180-degree flip here.
This is why they pay us the big bucks. And then,
You get paid? Hey, what's
we
going
get
on?
we're getting paid in exposure. Uh,
That's lovely.
yeah. So, and then we have the Orionids meteor shower. So you're gonna see the radiant in the constellation Orion, and that yeah, I'm sure people are gonna have spectacular images of the Orion Nebula and the molecular cloud complex. Be very exciting. And then we shall have a full moon right around my birthday, the hunter's moon. Um,
Lovely.
I'll take it, thank you. And that's pretty much all for October. It's gonna be yeah, meteors, some fun planet stuff. The winter's always good for planet stuff. And yeah, you want to take us through? Why don't you do November and December, David?
Okie dokie. Yeah, the northern hemisphere winter well, it's obviously late fall, it's not quite winter, but it's lovely because the nights are so long, and so
Yep.
you get a chance to see such a large amount of things. As
Oh
growing
yeah,
up in Wales, sometimes the sun would set in the middle of winter, so you're talking Jan, yeah, late December, early Jan, so late autumn, early winter. The sun would set about 3:45, and then it would rise, super late, about 8 o'clock. So you have these very, very long nights. Just amazing to sort of catch up on your astro visions.
it's perfect.
Yeah, be lovely. Okay, so November of this year is going to be really nice. So we have another meteor shower, the Taurids. So that is obviously in the constellation Taurus, just above Orion, actually. And you can see Taurus really nicely. It's typically right near the Seven Sisters, Messier 45, sometimes called the Pleiades. And Taurus is typically, it's the constellation that looks a bit like a V, and you've got a very bright star down here, Aldebaran, which is a beautiful star. I think it's a K5 dwarf. Is it K5? I think it's K5. Um, very nice red dwarf there, and it's sort of fairly bright, easy to see. So we'll have a nice meteor shower at that radiant. A new moon on the 9th of November, so pretty nice there. And yet another meteor shower in Leo. So this is the other side of Orion, as you go through Gemini and then into the very nice triangular head of Orion, of Leo, sorry. So you'll get another meteor shower on the 17th and 18th, just about a week after the full moon, the new moon, sorry. So you'll have to contend with about a 50% waxing moon, so not ideal. And then we have another Mercury elongation, greatest western elongation this time. So it'll be about 19.6 degrees away from the sun, on the eastern sky. So obviously just before sunrise. So very, very nice. And then we get another supermoon, the second of the year, in November, 24th November, the full moon, sometimes called the beaver moon or the frosty or dark moon. And again, for similar reasons that Joseph explained earlier, the moon will appear slightly larger, just part of its orbital mechanics, just it is slightly closer to the Earth than usual, and so it does appear slightly brighter and slightly fuller, slightly larger. And again, a couple of percent we're talking, not the massive tens of percent that you see in the movies. And then on the right at the end of November as well, we have the opposition of Uranus, as Joseph showed us before. Again, really difficult to see unless you've got a pair of binoculars or a nice telescope. Typically, you need 4-6 inches or above, and you'll see the Uranus at about its brightest that it will be for quite a while. So yeah, very nice November there for us. And then moving into December, as things really start to chill down and get cold up here in Massachusetts, We'll have a new moon on the 9th of December, followed by a full moon, another supermoon on the 23rd of December. So just before the Christian festivities on the 25th. So quite nice. That's sometimes called the cold or the long nights moon. Again, really nice, very full, very bright, slightly larger. If you can, certainly if you can photograph it down near the horizon, you'll see some really nice scale factors there with some trees and houses, as Joseph described for us earlier. And again, one of my favourites on the 21st of December at about 20:49 in the evening, Greenwich Mean Time or UTC, we will see the northern winter solstice. And that is essentially when the sun is at its very most southerly point, minus 23.5 degrees below the equator, south of the equator, I should say, which means it's the start of winter for us here in the northern hemisphere. And for those folks down in New Zealand and Chile and Australia and so on, it's the start of their summer. So very nice. And then one more meteor shower to mention. We have the Geminids, obviously radiant, coming out of the Gemini constellation on the 13th and 14th of December. But again, it'll be a few days after new moon. So actually, that's not bad. You'll have a waxing moon of a thin crescent. So it should be a fairly dark sky for looking for the meteors coming out of Gemini.
Geminis are going to be good this year for sure.
Yeah, I think they will. They'll be really nice, actually. So that's one I actually like that meteor shower.
I think that's a full year.
Yeah, it's a full calendar year, an Astraveo year, if you will.
Ooh.
Yeah, so I sort of turned that into a nice turn of phrase there. But some really exciting things. Joseph and I, we're really big into solar and lunar eclipses, as you know, if you've seen some of our earlier videos. Obviously, we did a really nice documentary, and Joseph put in the lion's share of the work there. Beautiful demonstration of Galileo's method of the orbital periods, the orbital motion of the Galilean moons. We'll see Jupiter's going to be wonderful, wonderful this year, earlier in the year, as we discussed, especially as it's opposition. So super bright in January, visible all night, and those Galilean moons will be moving backward and forward. Lots and lots of meteor showers. We're going to be, obviously they happen every year, but you know, we in the calendar that we're going to give the link to in the description, you're going to see when those meteor showers coincide for favorable viewing with the moon phases. And of course, Mercury's the big star of the show this year. I think Mercury's going to be really nice. It's going to be visible many months. With really nice elongations away from the sun. So you'll get lots of sunsets and sunrises where you'll be able to pick out Mercury and get some of those really nice photos that you're so good at, Joseph.
You too. Half of these are yours.
Thanks, man. So, yeah, this was fun. I really appreciate it, especially so soon after we did the last one with the, embracing aliens a few days ago.
I'm a believer now.
Yeah, well, there you go. Well, but I think we're also going to commit to doing as many of these coast to coast as we can this year. We've been a tiny bit busy the last 12 months or so with various things in our scientific and personal lives,
which we will have some fun updates on in a future podcast or video.
Yeah. I think you're going to have the most fun updates, but. But yeah, we'll talk about. I'm really looking forward to hear about some of your research, Joseph. And I'm definitely going to come and visit you when you move to pastures new, and we're going to have a lot of fun, I think.
Thanks, David. You too.
All right, take care. I really appreciate your time today.
You too, and thanks everyone for listening. See you in the next one.
I love you, brother.
Love you too.
Ciao, bye.
Okay, and how do I stop recording?
Well, this wraps up another presentation for Astraveo, where we go from geek to chic by sharing our passion and excitement for all things scientific, especially astronomy and in the mysteries of the universe. If you enjoyed this video, please hit the like button, and in the comments below, please leave us your suggestions for future presentations. We'll get right on it. And don't forget, you can join us on our journey by subscribing and hitting that bell. He's Joseph, and I'm David, and together we're Astraveo. Thanks for watching.